going to be an introduction video on Apache Spark. Let us talk about evolution of Spark. We all know that Apache Spark is a very popular framework in the field of big data. When we think about scale, we cannot help but think about the ability of Google search engine to index and search the documents that are present on internet at a lightning speed, right? The traditional storage systems such as RDBMS or imperative ways of programming were not able to handle the speed or scale at which Google wanted to build and search internet's indexed documents. This led to creation of Google File System and Google MapReduce. So Google File System provided a fault-tolerant and distributed file system across commodity hardware in the cluster, whereas MapReduce introduced a new parallel programming paradigm for large-scale processing of distributed data present in GFS. This MapReduce will send computation to the data based on data locality instead of bringing data to the application. So based on the GFS paper, Yahoo developed HDFS and Hadoop MapReduce. So Yahoo developed HDFS and Hadoop MapReduce as a framework for distributed computing and donated this to Apache Foundation in 2006. From then it became Apache Hadoop Framework. Apache Hadoop Framework is widely adopted even outside Yahoo, but this MapReduce on top of Hadoop had few shortcomings. So let us now see how a MapReduce job runs in a Hadoop cluster. So let this be our Hadoop cluster. A MapReduce job will be running as a pair of map and reduce tasks. For a MapReduce task to run, it has to read a data from Hadoop and perform map or reduce, then write the intermediate result to disk. A data job or a Hadoop job will contain a set of MapReduce jobs. So MapReduce 1 plus MapReduce 2 and so on, depending on the size of data and the complexity of transformations that are happening inside the MapReduce job. So once the intermediate data is written into disk, for the next MapReduce job, it has to again read the data, perform map or reduce, and write the data back to the disk. So for the series of MapReduce tasks like this, there will be multiple reads and writes happening until the final result is written into the final HDFS location. So with large batches of this map and reduce pairs running, each MapReduce pair intermediate result is written to disk for the subsequent stages for its operation. This will result in disk IO, sometimes blocking the performance. There are scenarios where it took more than hours or days for a MapReduce job to get completed. And the other reason or other issue with Hadoop is that Hadoop MapReduce is good for large scale batch processing, but it fell short for other use cases such as machine learning applications, streaming applications, and interactive SQL queries. So to handle these new workloads, engineers developed Mahout, Storm, Hive, GraphX, and similar applications like this, which had their own cluster configuration and their own APIs. So it has increased operational complexity and learning curve for developers. And in 2009, at AMP Lab in UC Berkeley, right, some of the researchers who previously worked on this Hadoop MapReduce, they took this challenge and they started with a project called Spark. This is where Spark is started. and they acknowledge that this map reduce is inefficient for interactive and iterative computing jobs, and it's also a very complex framework to learn because it is adding lot of other tools to handle the new workloads. Like for any machine learning applications we need to learn Mahout, and for building any streaming applications so we need to learn Storm, and for writing any SQL queries on top of data that is present in HDFS we need to implement Hive, and graphics for graph processing. So this is going to be a very big tech stack to manage and for developers to learn. So the idea of Spark here is to build a simpler, faster and easier framework, and early papers published on Spark has demonstrated that Spark is 10 to 20 times faster than MapReduce. And today it's many orders of magnitude faster compared to MapReduce. So the Spark project is borrowed from MapReduce and adding highly fault tolerant and more parallel support, and support in memory storage for the intermediate results between the iterative and interactive map and reduce computations, and support other workloads such as machine learning, streaming, SQL in a unified manner. And by 2013, Spark has gained a widespread use, and some of its original creators and researchers donated this Spark to Apache Software Foundation. Then it became Apache Spark. And at the same time, they started a new company called Databricks. The engineers from Databricks and community of open source developers worked to release Spark 1.0 in 2014 under the governance of Apache Software Foundation. After the release in 2014, Spark became very successful and most contributed project in Apache Software Foundation.